Nefertiti and her twin sister, let's call her Hepzibah, don't have a bad life. They walk around arm in arm, looking a little scary. As they walk by, they hear molecules mutter, "Oxidize anyone, that one." And they can hear the distant sound of bacteria scuttling into the distance, afraid of what they might do. One day, though, something strange happened. They were used to photons coming and going, tickling their electrons. But one day, a photon arrived with a much bigger energy than usual, and in a picosecond, everything changed. The two atoms were split asunder forever. Nefertiti picked herself up, counted her outer shell electrons. 1, 2, 3, 4, 5, 6, 7. Yes, she'd split homolytically. She had got herself her full set of 7, and her sister, wherever she might be, had 7 too. So she thought, hey, this is new. I'm a radical. And she set out for a new adventure. Now the thing about radicals is they're not choosy. When they meet someone, they go for it pretty much every time, no questions asked. So when Nefertiti bumps into a methane molecule, we all know what's going to happen. It's that gap in Nefertiti's outer shell that does it. Anyone she meets spies that gap and says, I want to put one of my electrons in there. And that's what happens. So, no trouble at all, she lures one of those hydrogens out from the methane molecule and turns herself into a hydrogen chloride molecule. What she leaves behind is the broken wreckage of a methane molecule, CH3 dot. And he's going to go on and have his own adventures, but she doesn't care, because she has moved on as HCl. This is what happens down here. And we all know that that's going to lead to a whole lot more stuff going down, because this is a propagation cycle. But Nefertiti has become HCl, and that set her on a whole new course. Now, being a part of an HCl molecule's not so glamorous, really. People say you smell disgusting, and if you dissolve in water you turn into hydrochloric acid and people dismiss you as a common acid. But actually HCl can do all kinds of stuff, and Nefertiti's molecule has something more interesting in store, because what happens is that they meet a propene molecule. Now, the thing about an alkene is that it has a pi bond, and a pi bond is something special in chemistry because it confers a kind of reactivity that most molecules can only dream of. So remember the story. Here's your propene, and the pi bond looks like that. It's twin clouds of electron density either side of the plane of the molecule, and that means accessible electron density, something that other molecules, like maybe this one, can get their teeth into. Now the point here is that Nefertiti is a whole lot more attractive than the hydrogen is. Let's make no bones about that. She's happy with that. People admire her as she goes past and say, wow, she's so attractive compared to that hydrogen. But it has an impact when it comes to this reaction, because it means that this hydrogen is delta positive and the chlorine is delta negative. So as they approach the alkene, they're going to approach this way round. because this hydrogen's having electrons pulled away from it by the all too attractive Nefertiti, which gives it a partial positive charge, and that makes it actually attractive to this pair of electrons, and that kind of annoys Nefertiti because she's used to being the attractive one, but hey, that's the way it goes. So this hydrogen sitting there, partnered still with Nefertiti, starts to think, actually, I rather like the look of that electron pair there. And the closer it gets, the stronger the attraction gets, until eventually this pair of electrons, disgruntled at being stuck in a pi bond when it would rather be in a sigma bond, goes for it and makes a leap for the hydrogen. Now something immediate and visceral happens at that point, because this pair of electrons is appalled. The repulsion it feels as the pi bonding pair clamps onto this hydrogen can't be overstated, and this pair of electrons just runs for it straight into Nefertiti's waiting arms, and that happens. So the bond with hydrogen, gone, and this electron pair, now Nefertiti has them all to herself. So what we get at this point is an intermediate which looks like this. Or maybe it looks like this. Because that's one of the interesting turning points in the story, where two possible things might happen, because it all depends which carbon manages to grab the hydrogen when all this happens, because it could go either way. It could go onto here, it could go onto here. So you know the story, that which one of those things happens depends on which of these carbocation intermediates is more stable. And the answer, of course, is this one. Because here, that carbon is stabilized by having, or rather its positive charge is stabilized by having two other carbons attached. It's a secondary carbocation. This one has only one other carbon attached. It's just primary. And that makes it much higher in energy, much less favourable. So the hydrogen says, yeah, I'm not doing that. This is what I'm going to do, because it puts me in a lower energy state. So we get this intermediate. And Nefertiti, meanwhile, basking momentarily in the joy of being a free anion, a negative ion, suddenly finds herself, not having had time to escape, drawn back in towards this positive charge. And there's nothing she can do about it, because that attraction between her negative charge and this positive one is just too strong. And so, with her newly minted lone pair, she plugs it into that carbon, which has only 6 electrons in its outer shell, and a new bond is formed. And so what we get is this molecule. So Nefertiti has become part of a 2-chloropropane molecule. Now we can summarize that whole exciting story just in a simple equation, which is HCl plus propene goes to that. But you need to know the details. You need to know all of that exciting stuff that happened that got her from being part of this molecule to now being there. So, being part of a 2-chloropropane molecule, well, that's not so bad for Nefertiti, because once again she's more electronegative than the atom she's bonded to, more attractive to their shared pair of electrons, so she's a little bit negatively charged. She gets admiring glances as other molecules walk by, and seems like maybe she could settle down there for a while, except that more adventures are destined to come her way, because floating around in the gas phase, she suddenly falls into a vat of sodium hydroxide solution. Now, the thing about sodium hydroxide solution is that it contains lots of hydroxide ions. The clue was in the name there. And the thing about hydroxide ions is that they are nucleophiles. Now, nucleophiles have got electron pairs, lone pairs of electrons, which they flaunt in the face of polar molecules like that. And interestingly, it's not Nefertiti they're attracted to. She's not going to like this, because it's actually the delta positive carbon that's the attraction here. So the nucleophile flaunts its electron pair. This delta positive carbon says, I'm going to have a piece of that, and so this happens. And so Nefertiti gets that strange feeling that she's had before, just like it happened when the HCl molecule was attacked by an alkene. Now the haloalkane molecule's being attacked by OH minus, and the same thing happens. Pair of electrons comes in here, and this pair of electrons gets bumped out of the way, and she suddenly finds herself thrown away. Extra electron in tow, and we get this. So here's the new molecule, but what's happened to Nefertiti is that she has got what was the bonding pair of electrons now all to herself, and she has become a free chloride ion. Except, of course, this is all happening in aqueous solution, so she's not as free as all that, because she's going to be surrounded by water molecules forming their ion dipole forces, keeping her in that solution. So she might wander around there indefinitely, and nothing might happen unless she meets another ion attractive enough to grab a hold of her and form something different. So most ions can't do that. She meets sodium ions as she wanders around, and they may experience a fleeting attraction, but it doesn't last. They soon go on their way. Even calcium ions, with their double charge, she'll look twice at them, but it's still not enough. She's still protected by her cocoon of water molecules, and the attraction she might feel for that calcium ion can't do anything about it. But there are certain ions which are just a little bit special when you're a chloride ion, and the one that she's hoping to meet will be a silver ion. Because the thing about silver ions is that when they meet chloride ions, their attraction is so strong that the water can do nothing about it. The water molecules have to release the chloride ion, and negative ion, positive ion bed down together, form a precipitate, and that is a whole new compound. So the reaction, and this is what's happening in Nefertiti's dreams, because she hasn't met the silver ion yet, but one day she will, and when she does, this is what's going to happen, and we'll get a snow white precipitate of silver chloride. And that will be the end of our story.